Welcome, ladies and gentlemen. So what I'd like to do is show you how to evaluate for a given function. And basically what we're doing when we have a function, we got to kind of know the parts of the function. And we'll just start with, an f of x equals, let's just do, x squared plus 4. Just going to do some kind of basic little introduction again on functions. So again, we have this f of x, and basically the f of x is, or really we can even just say the name, the f is going to be like the name. So just like I have a name and you have a name, all these functions we can give them different names. And we use different names just to differentiate the one function from another. Because you can see how f of x is different than g of x, and g of x is different than h of x. So that basically applies to your name, the f of x, g of x, and so forth. What's inside the parentheses is what we're going to call our input variable. Now, the main characteristics of a function is you're going to have an input and an output. And for every input, you're going to have that unique output, right? So when it's the name of whatever the input, that's going to be telling you what you're plugging into your function. And this is going to be your rule of your function. So your rule you can see here is we have part of the input is a part of that rule. And then obviously all we need to do if we're looking to evaluate for a different value is replace whatever value is for our input, it plugs that value in for the input, and then what we'll get is the output. So for right now, it's the rule. But if we want to evaluate putting in a value, we can go ahead and get the output, which in this case would be equal to 4. So the output in that case is 4. But the output is 4 when the input is 0. And that's where it kind of gets into case. So what my purpose of this video is I'm going to go through 4 different inputs. So first, we're going to do 2 different values. And then you can also do inputs with expressions. And then I'm just going to kind of go over different types of functions that we can input and kind of see what happens and how that changes as we change the input and the function. All right, so the first one is kind of a basic. And what I'm going to do is I'm just going to kind of go straight down the rows for each different input. So the first one, sometimes you'll see x equals 1, x equals -2. And sometimes you'll see it being used in function notation. So the way that we would represent this in function notation would look like this. F of 1 equals. So when x equals 1, right, basically what they're saying is what is the value of the function, or what is the output of the function when the input is 1. So in that case, a lot of times, instead of seeing it like this and the function, you'll just see it as f of 1 equals. And so all you're simply going to do is plug in a 1 for the 5. Now, for simple equations, you can probably get by without using parentheses. However, I would recommend whenever you're changing the input or whenever you're replacing an input with the value is put that value in parentheses. 1, it's going to help you avoid mistakes. And 2, it's also going to remind you, oh, yeah, I inserted that value in replacement of my x. OK, so there we go. Perfect. All right, so now I can just go and simplify. 4 times 1 is 4, plus 5 is going to equal 9. Moving on to the next one, I would have g of 1. So that's a different function. My input is still the same, but now it's a different function. So I'm going to call that g of 1. And therefore, that's going to be 1 squared plus 2 times 1 plus 3. OK, so 1 squared is 1, plus 2 times 1 is 2, plus 3. So that's going to be 1 plus 3 plus 3, which is going to equal 6. Here I have h of 1. Again, we're just doing the same thing. 1 plus 6. 6 plus 1 plus 6 is going to be 7. Square root of 7 cannot be simplified, so we'll just leave it as the square root of 7. I don't want to approximate to any kind of decimals or anything crazy here. J of x is going to equal 1 plus 2 over 1 minus 2. We'll just put my answers over here. 1 plus 2 is 3. 1 minus 2 is going to be -1, so that equals a -3. And the main important thing, is to go ahead and simplify these as much as possible as needed. But the main purpose of this video today is not to kind of go through every single simplifying technique, because you can kind of see the main idea of everything is fairly, actually, let's kind of put this down here. 3 over -1 equals -3. I did create space for that. OK, so here I'm just going to be plugging them in. And I really just want you to get used to plugging in these values and getting used to what it's going to look like. So therefore, that's going to be 5 over the square root of 3. You should be familiar with rationalizing the denominator. And so it really doesn't matter. I would say definitely depends on your teacher or the directions on the assignment that you're doing if it's going to be required to rationalize the denominator or not. So just go ahead and make sure that you are aware that when you can rationalize the denominator and when it's needed or not. Here, we're just using the absolute value. So we have 1 plus 1 is going to be 2 divided by 1. So therefore, that's going to equal the absolute value of 2 over 1, which is just equal to the absolute value of 2. OK, so there you go, ladies and gentlemen. That's basically it. You can see by plugging each one of those in. Sorry, you're going to have to kind of follow things. I didn't write in there exactly, but what we would really write is, if we were to rewrite this, f of 1 equals 9. G of 1 equals 6. H of 1 equals 7. And j of x equals -3. K of 1 equals 5 square root of 3 over 3. L of 1, I didn't write that in there. L of 1 equals the square root of 2. And that's how you would particularly write them in there. So let's just kind of go into -2, kind of see if that makes any kind of difference. I'll kind of work a little bit quicker because you can obviously see what is going on. We're just plugging in the values in for the x. However, I chose -2 because that does give us some different values here coming up that I wanted to make sure that I discussed. Here I have 4 times -2, which is -8, plus 5 is going to be a -3. Here I have g of -2, which is going to equal -2 squared plus 2 times -2 plus 3. Remember, whenever you have a negative number squared, it's going to be turned positive. So that's a positive 4. That's a -4, so it goes to 0 plus 3. So that's just equal to a positive 3. Here we have h of -2 equals the square root of x plus -2. Oh, I'm sorry. What am I doing? -2 plus 6. Again, remember, I'm entering these into their parentheses just so I can make sure I remember that was what the input value was. So -2 plus 6 is going to equal to a square root of 4. And square root of 4 we can simplify. Unlike the square root of 7, we can simplify that to a 2. OK, over here we have j of -2 equals -2 plus 2 all over -2 minus 2. Well, -2 plus 2 is equal to 0. -2 minus 2 is -4. However, whenever you have 0 in the denominator, it doesn't matter what it's divided by. It's always going to equal 0. OK. Over here, we have k of x. K of -2, I'm sorry. So we'll have -2 plus 4 all over the square root of -2 plus 2. So again, we have -2 plus 2, square root of that. So -2 plus 4 is going to be a positive 2 over the square root of 0. Well, the square root of 0 is just going to be 0. And anytime you divide by 0, you're going to have an undefined value. OK, so we can't divide by 0. So therefore, that value is going to be undefined. So we cannot evaluate for k of -2, or at least there's no value in for the function. And then last but not least is going to be L of -2. OK, and so we're just going to do absolute value of -2 plus 1 all over -2. So when we evaluate inside the absolute value symbols, we're going to do -2 plus 1, which is -1. So just remember, ladies and gentlemen, that the absolute value is basically going to be the absolute distance from 0. So if you have an absolute value of -1, that's just going to equal 1. 1 divided by -2 is just equal to a -1/2. All right? All right, so that's basically what you will get with numbers. And it doesn't really matter. You can do fractions, decimals. All you do is replace the input value with that value. Now let's go ahead and move on to variables. And variables is basically doing the exact same thing. All you're doing is plugging in those values. The simplifying, though, sometimes is a little bit different. So we have to simplify our expressions, which you're used to. But it's very similar, but it's also just requires a little bit different work. So let's kind of work on these exactly the same. Or let's kind of work on these, see what we get. So again, you're just going to change your input value to -x. So therefore, I have 4 times -x plus 5. So now when I plug in my new input into my rule, my output is not going to be a given value. So when I plugged in values, I got a given value for my output, right? Well, now I'm just going to get an expression as my output, which is perfectly fine. There's nothing wrong with that. It's just different than what we had from before. Here I have g of -x, which is -x squared plus 2 times -x plus 3. So -x squared is going to now be a positive x squared. This becomes -2x, and then that remains the same as positive 3. H of -x equals the square root of -x plus 6. So I don't really need the parentheses here. That's just going to be a negative x plus 6. So you can see how on some of these, they can be very, very easy, right? And some of them might require, a little bit of extra work. So negative x plus 2 over negative x minus 2. You can see here how this isn't changing at all. It's just going to be the exact same expression. So I could save some time and not even change that if I wanted to. Over here, you can see that if I was going to replace this with x's and negative x's, it's not going to change anything. Oops, I'm sorry for write that in there. So let me just actually write that in there, negative x. Let's save some time here. That's just going to be a negative x plus 4 all over the square root of negative x plus 2. And then last but not least, I have an L of x, which is absolute value of negative x plus 1 all over negative x. Now, what's important on this one is a lot of students will get confused when they go ahead and take a look at the absolute value and believe that the absolute value is going to undo this negative sign here. So that's not going to be the case because that only works when we're dealing with a that's only going to work when we're dealing with a expression that's not this is one single term, not when we're dealing with two separate terms, because we don't know what the value here of x is. So therefore, the final value here is just going to be absolute value of negative x plus 1 all over negative x. All right? All right, and then last but not least, the one that's probably going to deal the most algebra that you're going to have, but is the one that's really kind of preparing you for some different types of later mathematics, is when we need to evaluate for f of x plus 1. So we kind of do all of this to really prepare you, for something like this, where you're still getting a lot of the, you're just finding the value. It's going to be another expression, and it just takes a little bit extra math, but nothing crazy from you. So let's go ahead and see what we'll do here. So here I'm going to have f of x plus 1 equals 4 times x plus 1. So again, all we simply need to do is just apply a little distributive property. And you get, oops, I'm sorry, and that's plus 5, right? So you get 4x plus 4 plus 5, which equals 4x plus 9. OK, so just a little bit extra work here. This one is obviously going to take care of some more work here. So we're going to have x plus 1 squared plus 2 times x plus 1 plus 3. All right, so in this case, we need to expand this binomial. So make sure you know how to expand a binomial. That's going to be x squared plus 2x plus 1. Apply distributive property here, which is going to be a positive 2x plus 2, and then plus 3. Therefore, now I can just simplify my terms. X squared plus 4x, combine those terms, plus 6. OK? Over here, we're going to have, what am I doing, h of x. So h of x plus 1. And all we're simply going to do is x plus 1 plus 6, which you can see is just going to be the square root of x plus 7. Over here, we can have j of x, which is equal to x plus 1 plus 2 all over x minus 2 plus 2. Oops, x plus 1, where is it? Minus 2. OK. So therefore, we just add the numbers. We can't do anything with the variables. We're just going to add the numbers, which would be x plus 3 all over x minus 1. The next one here is k of x. So we'll do k of x plus 1. I'm sorry, I wrote that wrong. J of x plus 1. So k of x plus 1 is going to equal to x plus 1 plus 4 all over square root of x plus 1 plus 2. And again, we're just going to be adding the numbers to go ahead and simplify. So that's going to equal x plus 5 all over the square root of x plus 3. And last but not least, ladies and gentlemen, that marker is kind of bad. Last but not least, we have L of x plus 1. And that's going to be absolute value of x plus 1 plus 1 all over x plus 1. So therefore, we have 1 plus 1, which is 2. So we have the absolute value of x plus 2 all over x plus 1. So there you go, ladies and gentlemen. That is how you evaluate a whole bunch of different types of functions for different inputs. Thanks.